I'm going to start with the architectural template. Okay, so starting here with the architectural template, you guys have all used this tool before. Now with Revit 2018, this is the first year that we don't have the old school stair by sketch. Now those of you who've used Revit 2017 or earlier, if you look on the notes, you can see when you chose the stair drop-down, you had two different tools: stair by component, stair by sketch. Now we can still get access to the sketch-based tools, but what we have to do is go through the convert process that was there for the component stairs since they were first implemented in Revit. So let's just talk about that right now. Does anybody here do condos with really tight stairs? Like winders even on a house? Anybody ever done winders in a house in a landing? If you guys have ever looked at a winder-based stair, actually here I'll bring it up from the building code here. Okay, now I just got to find it. Give me a second here. We shall. There we go. Okay. So if you guys can see up on the screen here, winders in a stair. Now I think the code actually has, here we go. This is the sort of the minimum dimensions that the BC building code allows for doing winders in a stair. Now to do this, to do winders in a stair in Revit, I'll show you the tools that are provided and we'll just talk about how much they suck. So when you fire up the stair tool, the options that are presented to you on the ribbon do include a winder stair. So you got your straight stair, which we use most frequently, and then you can do, you know, curved stairs. And now you've got a chance to do a winder-based stair. Okay, now let's just look at this sucker and go, what is wrong with this picture? So the building code demands that you have all of your risers perpendicular to the direction of travel. So I don't know what planet winder stairs in Revit are based for, but it's not working here. So you still got the regular controls to adjust the number of flights, and then you can increase the number of, I guess I'm the wrong one, you can increase the number of parallel treads. 1, 2, 3, 4, 5, 6, 7, 8, 9, I can do maybe 10 there. And you can play around with this as long as you want, but you are not going to get anything that resembles a compliance path in Revit. So what we have to do is forget about using Revit's winders. They're terrible. So you start off with your inside the stair command with just putting in a couple of runs and then doing your return. Now what we have to do is convert the stair so that we can turn this into a sketch-based stair. Now those of you who have worked with the component-based stair will know that you can click on one of the runs or the landing, doesn't matter. So here if I click on this landing, for instance, you can see that there's a convert option. Same when I click on one of my runs. So inside the stair, while you are editing it, when you click on one of the runs or the landing, you can convert it. Now when you do this, you turn this thing into a sketch-based component. So when that happens, after you've converted it, now you can edit sketch. Well, this dimension is here, let me delete that. So once a run or a landing has been converted, you can edit its sketch, and now I can edit its shape. So I can get rid of the boundary lines here. And we're going to do this as a group in a few moments. So here I can, you know, make some different shapes from my landing. And so now I've got this, you know, crazy shaped landing. Now, if I'm doing something like the winders that we see here in the building code, you can see that there are very specific dimensions that are required to form compliance. So to do that, you actually have to start off by deleting your landing. And I'm going to add my landing to my upper flight. So usually that's what you'll do. If you're going to do winders in a single family residence, you'd start off by making your 2 flights and then adding the winders to the upper flight. So here I'm going to convert it and now edit the sketch. So here's how it works. You've got green boundary lines at the sides, and then you've got black lines, which are your risers, which must be at the top and bottom of the flight. So what we're going to do instead here is we're going to just very roughly here draw in the process. So you have boundary lines which will turn the corner here, and then you draw risers, so you can switch between drawing boundaries, which are the green lines, and risers, which are the black lines, which you can put in place. So I can do a 60-degree there, and I'll do, I'm not quite drawing this right. I should have the, so anyways, I am just quickly doing this here. I can't remember the exact dimensions without having that PDF in front of me from the building code. So I just want to make sure I have, it should be 30 degrees, and it is, okay. So then, this should be 30 degrees there, okay. Now just checking to see how wide this is. This is 3 feet, okay. So, just got to make sure my stair here is as wide. So like I said, boundaries go along the edges. And now I'll do another boundary here so I can do my last winder. There we go. So now trim and just clean this all up. So you can see that I have created sort of a 30, 60, 90 set of winders here, which the code allows, or you can do 0, 45, 90. So either way, this is how it's done. Now the only thing I have to finish is completing the stair path. So that's this blue, dark blue line. It's probably not easy to see it's dark blue unless I zoom in, but you can see there it is dark blue. That's the stair path line. And Revit wants you to complete that as well. So I'm just using the midpoints here. There. So now Revit is happy. And I've created a couple of extra bonus risers here that I'll be able to remove from my bottom flight. Now I need a landing, so after I'm done with my sketch here, you can see I've got 3 risers to lose, so I can lose them from my bottom. Now when you're playing with your stairs, remember that when you click on these stairs, there is a dot handle which allows you to add or remove risers from the stair. Now I should mention something here. This is the bottom of the stair. Now dragging the dot handle at the bottom of a stair, and you should actually, I'll make a note of this again in the notes when we're talking about these handles on page 3. So I'm actually going to drag the handle at the top of the flight, of my lower flight. So this is the bottom of the stair, this is the top. So here I have to drag it from the top, and that's fine, and then I'll use the move command and move this over. Now that's actually, I could balance this. I'm going to move this down one riser. There we go. And add one more riser there. So now I need a landing between my two flights. So I can use the landing tool and then just pick them both. And Revit automatically creates the landing between. Oh, it's not going to do it. Okay, so in this case then I'll have to draw the landing myself. So with the landing, I draw my boundaries here. And I draw it to the inside edge of the stair. Here you can see the thing on the outside, that band that's around the outside, that is the stringer. We'll be talking about stringers in a few moments as well. There we go. And also have to continue the stair path as well, so I'm connecting to those other two lines in the flight. Delete some of these intermediate supports that Revit has been drawing for the boundary, and let's just see how well we're doing here when this is done. Now you can see here the landing is not properly connecting its or getting its height here, so just got to remember how I get this thing back down to the level of the rest of the stair. Maybe it's 0 here. Nope, I'm going to have to come back to this. I've done it wrong, but this is the process anyway of creating the winders. I'll have to do this and show it to you guys later at the break. So just be aware that the process of using these stair winders here isn't going to work in terms of the building code, and you will have to draw these winders much as I've shown here by converting it and then editing the sketch. So I'll have to come back in 5 minutes once I've figured out what I've done wrong. So that's an aside. Now, generally speaking, when you create the stairs, you have the 3 tools. Look at the bottom of page 1 here. So with our component stairs, we've got 3 parts. Okay, so I'm going to pull up the properties palette here. We'll talk about what's in our stair. So with your stair, when you go to its type properties, so here's the type properties of a stair. So you can fire up the stair command and then immediately go to edit type in the properties palette. And now we're going to talk about the different parts of the stair. So you've got the run. So you folks can see here we've got the run type. So what this defines is the configuration of the riser and the tread. So this run type here that you see is actually stored in the project browser under stairs and here under non-monolithic run. Now when we started up the stairs command, it automatically put us in what's called the assembled stair. There are 3 different kinds of component stairs. There's assembled, and then the 2 different kinds of concrete stairs, cast in place and precast. So both of these are your concrete stairs, and then the assembled stair would represent a wood or a steel stair. So right now we're starting off and talking about assembled stairs. And assembled stairs are comprised of the non-monolithic run, non-monolithic landing, and supports. So the run object, let's talk about that first. So under non-monolithic run, this is it right here. So go down in the project browser under stairs, expand it and find non-monolithic run and expand that. So if we double click on that now, Revit's going to pop up the properties of this run. Now you could use this run that we see right here, the 2-inch tread, 1-inch nosing, 1/4-inch riser. This configuration for the steps can be used by multiple different stair styles in your project. So just like with railings, as we'll see in a few minutes, this set of settings here for a run can be used by various different stair styles. Now, let's go ahead and duplicate this run style. So in the style like box here, choose duplicate. And we will call this 2x10 tread, 1/2 inch riser. So this would be a single family house, minimum stair allowed under Part 9 with a 1/2 inch plywood riser. So you can see what's happened over in the properties palette. We've got the two different run styles being used. Now this run style we've just created, 2x10 tread, 1/2 inch riser, is not yet being used by any of our stair styles. So once you've got a run type that you've created, then you've got to put it into one of the stair styles that you have in your project. So what are we going to do here? Well, what's the thickness of a 2x10? Anybody? 1.5 inches. So 1.5 inches. Now, in terms of the nosing length, here for the profile, it's using like a 45-degree bevel on the bottom of the nosing, and it makes it protrude 1 inch. Now, if we want to just have a square nosing, switch to default, and this will just simply make a rectangular front to your stair, and a 1 inch nosing is okay. Now, with our riser thickness, we'll make it 1/2 inch. And I think that's all we need to do. Now you can see here we can't specify the depth of the tread. So really, I should rename this and just call it 2x tread. We are going to make it as a 2x10, but that'll be defined by the stair style. So what the run style merely does is define the tread thickness, nosing length, and whether you have a profile family that's being used at the front of the tread. So if you want to make a curved front to your tread, you could have a profile family that would facilitate that. And then your nosing as well. So there's your riser, all that stuff, it's done. Now, of course, the only thing is that I do not yet have a stair style that's using this run style. So you have a run style and it gets built into a stair. So let's do that next. Okay, so we've got our assembled stair here, which has a 7-inch riser and an 11-inch tread. So if you guys were in the middle of a stair sketch, that's cool. Just stay where you were. If you're not in a stair sketch, then you need to go to architecture and fire up the stair tool right now. So as soon as you've started up that stair command, we're going to go over to the edit type button here, and we are going to make a new stair type, and we will call this Part 9 Min Stair. So this is a Part 9 minimum stair. So if you folks are doing residential housing and you want the smallest stair footprint possible, this is it. So hit OK. Okay, does anybody know off the top of their heads what the maximum rise is for a house in Part 9? 200 mils. So you can actually put in 200 millimeters and we're able to do the conversion. Now the minimum run allowed in Part 9 is 210 millimeters. So you can put in 210 millimeters. So for my riser height, I just put in 200 millimeters there. For my minimum tread depth, now this is a little bit deceiving. What Revit calls the minimum tread depth is actually really the run. Now you guys know that there is a difference between the run and the tread. So in this case what we're having is a 2x10 tread, so that's 9¼ inches. And then we're going to have a 1-inch nosing here. So really, what this is going to be is the run from the front of the tread to the next tread. That's going to be 8¼ inches. And that turns out to be 210 millimeters, almost spot on. So, let me see, I put it in here. 210 millimeters, so I'll just clean that up. I'll just make it 8 1/4 inches. 8.25 inches. Okay, so that's good. And now, minimum run width, it's 2'10". That's about 860 millimeters, 880 millimeters. I know it's 2'10", regardless. So 210, that is your bare bones minimum stair in part 9. So now, we need our part 9 stair to use the run that we defined over here. So we switch it from this 2-inch tread, blah, blah, blah. And now, we can choose the 2x tread with the 1/2 inch riser that we defined moments ago. So now, this run style is being used by our stair style. So Revit has all of these different components, these different pieces that plug into a stair. So if we just do a little diagram here, you've got your stair style, or stair type, the terms are interchangeable. And into this, we have a run, we have a landing that plugs into the stair style, landing, and then we have supports. So all of these 3 different parts of stairs are all fed in to the definition of an assembled stair. And we can see all of that in our Type Properties dialog box. So there is the run and the landing right here. Now, landings are actually super basic. If we go down into the non-monolithic landing, you can see there's only one style here. Check that out. Same as run. So basically Revit is asking you, hey, do you want to make your landings build them the same way as your run? And it's like, yeah. And if you choose no, then you can choose a different configuration for your landings, for what happens when you hit the landing with your stair. So this would allow you to have a little bit more individualization between the landing and the run. But generally speaking, you just use it to be same as run. So now the third component here that we haven't talked about yet are the supports. And we'll get into that in a few minutes. So let's go over to page 2 here and just talk about the project browser. Now, the project browser with railings and stairs does not intuitively organize information for you, and I'm not too happy with how the software has been set up to do this. So if we look in the project browser, I'm just going to circle the stuff that's bolded in your notes. There's the folder here that lists all the different kinds of assembled stairs that we've defined so far. And here's our cast in place stair. So that is our concrete stairs that are built on site. And our precast stairs, which are precast concrete built and flashed somewhere and then trucked to the site. So in these 3 folders are all of the different stair styles that you would use in a project, and that's why they're bold ticks. You can see that there's one extra one on the precast here. This is stair. This is the old school sketch-based stairs, and no way. Wow. Okay. You know what? I'm just going to. This is the moments where the instructor yells "squirrel" because I just noticed something. In Revit 2018, sketch-based stairs have been removed. It's not in the interface anymore. But it looks like we can actually just draw them. See, if I drag and drop this into the view, did you guys know this? If I grab one of the walls out of the list here in the project browser, you know, I go down to walls and I expand it, and I drag and drop that wall into the view, I start drawing that wall, right? And then if you go down into the Windows folder and you find a window that you want to use, to drag and drop that into the view, and it starts the window command, and you can put that window into the view. Any of the stuff that's in your project browser, just go and grab it, drag it into the view, and away you go. So there's my curtain wall. Start drawing with curtain wall. So likewise, with this stair, you know, if I choose my, what is it here? What the heck is it? Non-assembled stair. It's been a long day. So here's my Part 9 minimum stair. Drag and drop it into the view. Starts the stair command. I draw my stairs, and done. So what I'm finally getting at is that the ye old Revit stair types here with the sketch-based tools, the sketch-based tools from the outset, they're still here. Drag and drop it into the view. Isn't that? Oh, no, wait. Oh, Revit, you dog. Nope. Nope, nope, nope. That's not the old school stairs. If this was the old school stairs, all of my riser lines would be black, and I'd have the green lines on the side. So that is, I don't know what that is. That's that's deceiving. So if you look on page 2 of our notes, you can see under precast stair there is just plain old stair, sketch-based stair style. So that's the old way, the old school way of making stairs in Revit. And they've got that folder here in Revit, but it does not make those kinds of stairs. So I don't know what the programmers are doing. Someone needs to give our Russian programmers better vodka, because so if you see sketch-based stair styles on page 2, that would be the case in Revit 2017 or earlier. With Revit 2018, it just makes some more of the so-called component stairs. All right. So just a few notes here about placing these stairs. So bottom of page 2, using the stair component tool. Now what do we mean by a component stair? Well, it used to be, if you're using Revit 2017 or earlier, that when you used the sketch-based stair, so you can see the two options on the first page of our notes, you wouldn't be able to see this. Now what I mean is this. I haven't finished the stair yet, right? It's still in the process of being done. But right now, despite that, I can go into 3D and I see a three-dimensional representation of my stair. If you folks are using Revit 2017 or earlier, and you use the what's the tool? What's it called? Stair by Sketch on page 1. You won't see a 3D stair while you are editing it. All you would see is on level 1 a set of green and black lines, 2D, sitting on the floor until you finish it. So the advantage with the component stairs, you can kind of see what's happening and see if you're liking what's going on before you commit to finishing it. And of course when you finish it, Revit puts on the railings as well. So that was one of the advantages of the component stair, and there's some other ones that we'll go and talk about as we go along tonight. Now, I don't know where my stair went. Okay. So let's just place a set of stairs here, and we'll talk about the controls that we have. Now, when you are using the Run tool, Revit automatically creates a landing between the stairs. So those of you who've been working the stairs, you know this. So you put in one flight, and if you go all the way to the end, you'll get all the stairs that are required to go from level 1 to level 2. Okay, so that's old news. Now, if you don't make it all the way to the end, now you can put the next flight somewhere else. So if you are making a straight stair and you just want to put a landing in between the two flights, there you go. Or if you want to make the stair a switchback stair, start across, and come back. So what happens is each pair of clicks with the run tool creates a flight. So what Revit calls a run is one flight of stairs. Now, if you want to add or remove risers from the flight, when you click on either one, there is a triangular arrow, which if you drag it, it will add risers or remove risers to the other flight. So here, if I drag it, you can see it's changing the number of risers on this flight and adding the corresponding number to the other flight of stairs. Now, I haven't noticed this in maybe a year. This may be something that the developers have sorted out. But sometimes what I'd notice is that when I was drawing my stairs in, you folks can see how there's numbers for the first riser and last riser of each flight. Sometimes I would notice is that it would go from 1 to 9. There would be a 9 right here where my cursor is, but I would see a line as if there was going to be a 10th riser, but no 10 there. And that is because sometimes Revit would lose its brains and do this. That's exactly what I'm talking about. It looks like this should be the 10th riser, but when you click on the flight, and you click on the run, this box is unchecked. You didn't uncheck it, the software just did it. So I think that is a problem with earlier versions of Revit that has been solved. So a lot of the stuff that you see on page 2, I don't think you'll have to worry about it if you're working with Revit 2018 or later. Now, what I want to talk about is a situation where you have a very large floor-to-floor height that you need to traverse with your stair. Now, I worked on a transportation project years ago where we had a platform for a public transit system which was well above the street. So I think it was about 6 stories above the street, in fact. And we needed to draw a set of stairs that was going to traverse that distance between the street level and the platform. So if you are drawing a set of stairs in Revit, you can have that really high distance and traverse it with one Revit stair. Now here's what's going to happen. I've got to go 48 vertical feet. So as you know, we can go about 12 feet before we need a landing. So I can go up, and you'd have to do the math to figure out how many risers you'd have to go up. But you can draw your stair, come back to the other side beyond the landing, and of course do the one riser offset so you don't get a weird gooseneck in your stairs. Come back and go to the other side. And then come back to the other side, keep going. And what we're doing is we're actually stacking the stair on top of itself. Now it's a bit of a mess to try and figure it out on plan, but if we go to 3D, you can see that the stair is in fact turning around on top of itself, and when you're done, Revit puts in all the handrails that are needed and everything works out fine. So just be aware that you can, that this is a possibility when you are putting the stairs together, and you can just ignore, there was an error there. So when it's done here, you'll just see the error. What Revit is griping about is that the railings are directly on top of each other. Well, of course, that's what we just did here. We did that thing in loops. So you might think, well, that's not good. But as it turns out, it's okay. Revit can handle that, and it's quite all right to draw a stair that traverses all of that height. So that's all I want to say about high stairs. So I'm going to delete this stair now. And we'll just talk about the landing tool here for a moment, and then we'll take a break. So what I've just done here is I've just changed my floor-to-floor height back to 12 feet. And we're going to go on and talking about the landing tool. Now, when you are putting a landing in your stair, or when you're designing your stair, you might be kind of trying to figure out, you know, where your flight is and trying to move the risers or the run up against adjacent walls that might be in the stairwell. So maybe here I'll just draw some stairs that go up to the next floor. Just drawing some walls in here so I can show you folks how we'd deal with putting a stair in place. So with my stair command here, I'm going to start working my way up, and then I'm going to come back and return around the other direction. So you started to create your stair, but you want to make better use of the enclosure that you are within. So while you're creating the stair, you can go ahead and grab the stair and move it, select everything, and move it into the corner of the stairwell that the stair is within. Now what I want to do is move this flight over so it's against the wall, and my landing will automatically adjust itself. So I grab the flight, use the move command, and move the stringer over so it's against my wall. Now, in reality, what I can do here is I can turn off my line weights, increase my level of detail here so I can see my gypsum board layers. So what I can do is, if I want my stringer to go right against the stud, I can select my stair and then move it so that the edge of my stringer goes up against my stud. And I can do that on all sides. So that way your stringer is directly attached to the stud layer in your walls. So here I'll just show you again. So you can see where the edge of the stringer is, that black line. I've got thin lines mode on so I don't have to deal with line weights. And I'm at medium level of detail so I can see where my gypsum board layers are. So in this case I've got 2 layers of gypsum board on one side and 1 layer on the other. That's not really the point. The point is that if I want to move a stair so that the stringer is against my framing, you click the run, and then you use the move command, but you're moving not from the edge of the tread, but from the edge of the stringer. If I can find it here. Here it is, there's the edge of my stringer. And move it sideways until it touches my stud layer. And now the edge of my stringer is right against the edge of my framing. Got one more bit of moving to do here, so I select the entire stair because I'm going to move it over so that the edge of my stringer here is against the edge of my framing for the wall, like that. So then this would allow you to make your stair as narrow as possible, and then you could, work out, how much of a reduction in your stair width that you could manage to try and give some of that room back to the rest of the building. So while you're working, you may inadvertently delete the landing in between your 2 flights. So if that ever happens to you, or you did an adjustment, you converted it and then you edited it as a sketch, and it's something that's screwed up, so you just end up deleting your landing. And if that's the case, unlike what happened to me earlier, you should be able to use the landing tool and just simply pick the 2 flights, and Revit will build a new landing for you. So that takes us to the top of page 3. And what we'll do now is we will take a coffee break for 10 minutes. We'll come back at 10 to 8, and we will carry on.